Okay, so this video goes over parallel lines. Now in this video, we actually are going to go over all of the reasons in parallel lines. And all those reasons are as follows. We have, and I'm going to go over this, don't worry, we have alternate angles are equal, we have corresponding angles are equal, and co-interior angles are equal to 180 degrees. Okay, so where do we start? What is parallel lines? Now, if you are familiar with your graphs or your linear graphs, if you have this line over here, let's just say, for example, we have this line over here, and we have this line over here. Okay, so we can see over here that obviously excluding the scale over here, we can see that these two lines are going in the same direction. They are both horizontal straight lines. So this means that the gradient will also be the same. If you are familiar with linear graphs and your y equals mx plus c equation. But what do we know about parallel lines? What indication do we use to actually show that these are parallel? We use arrows. Arrows indicating the direction. And also, we basically say that they are both going in the same direction, therefore they are parallel to each other, and they have the same gradient. That is what parallel lines are. Now, if we were, okay, we're going to put in angles in between for your other reasons, but this is just an introduction to parallel lines. Okay, so I think we can actually just jump straight into the rules or the reasons, each reasons. Which one should we start with? I think that we should start with alternative angles. Okay, so we are given these straight lines, and now I'm actually going to be introducing you guys to letters. Now, when we are naming straight lines, we are going to name where the line starts and where it ends. So as you can see, that this letter A, let's start with A, this straight line ends with B. It goes for all the way from A to B. So we will call this line AB. And as you can see, we have another line which starts from C and it goes all the way to D. So we can actually call this line CD. Okay, now how do we indicate parallel lines? Now, first off, we are actually given in an examination that the line AB and line CD are parallel to each other. And this is how it's indicated. They give us two lines over here. And that is what parallel means. As you can see, obviously the meaning behind this is that these two lines are in the same direction. They're both straight lines, and this indicates that they are parallel. That's like the symbol we use to say that two lines are parallel to each other. And then we obviously have a line FE or EF. And also, I just want to let you know that it really doesn't matter which order you actually name the line. So you can actually say that line AB is also line BA, as long as it's from the one point to the last point, and then that's basically your line. Okay, so now that we said that AB is parallel to CD, they would normally give you this in your examinations. They would normally tell you that they are parallel. Remember, we indicated with these signs. They will normally do it for us in the examination. So this AB is parallel to CD. That is our two lines that are parallel. Okay, so remember, here we have alternate angles are equal. Okay, this is our first reason for parallel lines. So as we can see over here, that we have a line EF. We are going to consider a random angle on these lines over here. Let's consider this angle X. We are going to say that this angle is equal to the angle that is alternative to this angle. Now, what are we talking about alternative angles? Let's look out, whenever you see alternative angles, we are going to actually look out for a Z shape. So a shape that is a Z. So as you can see, we have a shape Z over here, and it goes along down here to this line. Okay, that is not what I wanted to do. But we have it going down here, and then we also have it going here. So what we can see is a Z shape. And when we are talking about alternate angles, we are going to use these two different angles over here. Or not different angles, because now they are actually equal. But we can see that these two angles are actually alternative to each other in that Z shape. And this is where we say that these two angles are actually equal to each other. So once again, we have Z shape over here, and these two angles will always be equal to each other only if the two lines are parallel to each other, which is AB and CD in this example. Sometimes they'll rotate these lines around to make it look confusing, but at the same time we need to actually know from our information which lines are parallel to each other, and then we can actually look out for other lines that are going through other lines, which in this case EF is actually going through both lines AB and CD. And this actually causes these two lines or these lines to form an alternative angle, or two alternative angles, which is going to be X over here and also this angle over here, which we are going to call X. And because of our reason saying alternative angles are equal, we now know that these two are equal. So if I were to do this, right, if I were to give you an angle over here, right, I were to say this angle is equal to 35 degrees. Then this angle over here must also equal to 35 degrees. But how do we actually write this on paper? This is how we write down the answer. So we say that we are given the angle 35 degrees, but we want to find out what X is. Because of the information that we have line AB is parallel to line CD, and we have an alternative angle over here, which is a Z shape, which once again you have to look out for the Z shape. Okay, so let's do the example over here, right? We have X and we want to find X, actually. So we're going to do this. We're going to say X is equal to 35 degrees. And why is it equal to 35 degrees? And remember, we have to have a reason. This is how we're going to actually write down our reason. And I'm not going to cut the video for this one. We are going to write the following. We're going to write and use our reason. We're going to say that alt angles are equal. And then we are going to do the following. We're going to say semicolon. And this semicolon means because. Now we're saying alternative angles are equal because, and what lines are parallel? Because AB is parallel to CD. Note that if you don't say AB is parallel to CD, they will not mark your work, because you're not mentioning, you're not showing your understanding of the question. So that is what we need to do. We're saying that alternative X is equal to 35 degrees, and the reason alternative angles are equal because AB is parallel to CD. And that is how we write our reason over here. And that is alternative angles. There's not much to really deal with, but don't worry, this is just like the basics, and then once we get into, I'm going to do example questions and we're going to actually go through it together using all of these reasons. And let's go to the next reason, which is the second out of the third reason for parallel lines. Okay, so our next example here is on corresponding angles. Now our reason is going to be corresponding angles are equal. And now what does corresponding angles mean? Okay, so basically if we were to have an angle, and this is what corresponding is over here. If we have an angle, if we have two parallel lines, which is AB and CD, and we have a line EF that goes through these two lines as shown over here on the, over here right in front of us. Now we can see AB is obviously parallel to CD. If we are given, or if we are shown that two angles over here, so angle over here and an angle also over here. Because we have two parallel lines and we have EF going through these two lines, this will actually tell us that this angle here, let's call it angle X, is also the same as this angle here, which we also call X because they're both the same. Now, this is only true when we have parallel lines, once again. Now, let's just go straight to the example. This is what you must look at when you're doing corresponding angles. As you can see, there's going to be a difference between co-interior angles and corresponding angles. But right now, let's actually deal with corresponding angles. But let's actually say that they give us an angle. They give us an angle over here, which is going to be, let's say, for example, 70 degrees. they give us 70 degrees, and they say that we need to find the value of x. Now, how do we do this? Because of the information that we're given, AB is parallel to CD, we can actually say that x is equal to 70 degrees because they are corresponding to each other. And how do we write this down? We do this. We say x is going to be equal to 70 degrees, and we're going to write here the reason, which is going to be, we're going to say corresp. See my very beautiful handwriting, but we're going to write it short over here. Corresp angles are equal. And remember the semicolon, meaning because which lines are parallel? Because AB is parallel to CD. Because AB is parallel to CD. Okay. So that's basically, yeah, that's just about it. So for corresponding angles, you just need to be on the lookout for these patterns, basically. As you can see, it's more of like an if pattern. Like you can see like an if, but like an upside down if. Let me just try and point it out over here. So we have like an upside down if basically over here. And then we have this line over here and this line over here. That's like an if shape. Normally with these types of things, you need to look out for those patterns. And we already said that this angle is also going to be 70 degrees. There's not much to actually go over this one for, but let's actually just go to the last one, which is co-interior. It's going to be a little bit more tricky, but it's actually really still not that bad. Okay. For this one, we have the following. I know it's the same set of lines, but this time we're actually going to look at something different. Okay, so when we are working with co-interior angles that are equal to 180 degrees, please remember that. This is the only thing that indicates that the two angles are not equal, but they will equal to 180 degrees instead. So co-interior angles equal to 180 degrees. Which angles are we looking at? So the first piece of information, remember we always need to know this. First of all, in order to use this reason, we need to know that two lines are at least parallel. AB is parallel to CD, which is already given, and we have a line that goes through those two lines, which is EF. And we are shown that this angle over here is our angle X, and this angle, and it should be pretty obvious to you at this point. As you can see, angle X is much smaller than this angle, so we're going to call this angle Y. We can see that these two angles are not the same, because Y actually looks like an obtuse angle, which is an angle that's greater than 90 degrees and smaller than 180 degrees, and X is basically an acute angle, which is any angle that is lower than 90 degrees. But obviously the scale doesn't really matter. What we need to know is that these two angles will equal to 180 degrees. So what the reason says, co-interior angles are equal to 180 degrees. And what they're trying to say, the sum of the two angles will equal to 180 degrees. So if you add X and Y together, it needs to be equal to 180 degrees. Only under the criteria of where AB is parallel to CD, or if two lines are parallel to each other, if we do have parallel lines. And how do we answer this? Let's do this over here. So but first, before we answer this, we need information first. If we have this this angle over here is equal to let's say 65 degrees. This angle is equal to 65 degrees, and we need to find out what Y is going to be equal to. Like I said already, if you add the two angles that are co-interior, look how it's actually inside of the two parallel lines. That's what co-interior actually also means. It's the two angles that are inside of the two parallel lines, and those two angles, if you add them together, will equal 180 degrees. So this is how we do it. We're going to say Y plus 65 degrees. These two angles, if you add them together, they will give us an answer of 180 degrees. See if I can, 180 degrees. Doesn't look like the best 180 degrees, but it's fine. And we need to solve for Y. And we can get Y on its own, and we can say 180 degrees minus 65 degrees, because we're taking the 65 over, or we're minusing both sides by 65 degrees. And now we're going to get a y value that's going to be equal to 180 degrees minus 65 degrees is going to be equal to 115 degrees. Okay, now you're probably thinking over here, or you're probably saying to me over here through that screen, Dylan, but what about the reason? Well, I'm glad that you actually pointed it out. So we actually need to show why we got this. And the reason goes as follows. We're going to say the reason that we are actually working with, which is co-int angles are equal to, and not just equal, but they are equal to 180 degrees. You don't have to say equal 180 degrees, but I think it's also better to do this. I just do this because it actually helps me understand, like, okay, all of the sum of those angles are going to be equal to 180 degrees, basically. And we say because which angles are parallel, or which sides are parallel. AB is parallel to CD. That's the information that we do have. Okay, so there's our answer for y. So now we know that y over here is actually equal to 115 degrees, 115 degrees. And these two together must equal to 180 degrees. Okay, so that is about all of the different reasons that we are using for parallel lines. And the next videos are actually going to be going over not the examples that are used, but I want to actually cover all of the geometry, which next one is going to be based on triangle geometry, or geometry of triangles within Euclidean geometry. So this is all the types of straight line reasons that we actually have. So as you can remember, in the beginning we had straight line angles on a straight line. We had also vertically opposite angles, which didn't really deal with parallel lines, because those were its own things, basically. Just reasons that we actually had to know. And now that we're dealing with parallel lines, we have three different reasons in parallel lines. The first one is going to be alternative angles, where we must actually look for the Z shape, the Z shape, and co-interior angles, which we must look for the F shape, whether it's upside down or upright. And then we have the last one, which is co-interior angles, which are equal to 180 degrees. The sum of the angles inside of the parallel lines are equal to 180 degrees. Those are the three parallel line reasons that we have to deal with. And this is all of the reasons that we need to know for straight lines. And the next video will be going over the geometry of triangles. Don't worry, I will go over hectic examples, or I'll go over challenging examples from exam papers after all of the Euclidean geometry videos. Okay.